Good morning everyone, I am Mr. Ish. Thank you for joining me. In the past I presented two videos on these work problems which show up quite a bit on standardized exams. In this video we're reviewing that topic utilizing three problems. I will include the tag for those two videos in this video information. You can review that just so you can understand how the equations are developed, because here we're just doing a quick review of three questions. Question number one is this. We have a certain pipe. Pipe A working alone fills a tank in 5 hours. B fills that same tank working alone in 3 hours. Together, how long will it take to fill 2/3 of that tank? Again, pipe A is filling a tank in 5 hours alone, and then pipe B is doing that in 3 hours. If they work together, how long does it take to fill not the whole tank but 2/3 of the tank? Your equation will be here in terms of how long this time required to fill that tank to whatever capacity would be X. But pipe A is always doing 1/5 of the job each hour because it takes 5 hours. Pipe B is always doing that same job per hour in 3. It's doing 1/3 of that job every hour. So x over 5 plus x over 3 is equal to what would be normally a whole tank. But we're not talking about a whole tank, we're talking about 2/3 of a tank. So this will be 2 over 3. And from here you just solve for x. You'd have 15 over here. 5 goes in 15, 3 goes in 15. You know you'll have a 3x plus 5x is equal to 2 over 3. Here you'll have 8x over 15 is equal to 2 over 3. You'll have to cross multiply. 24x is equal to 30 and x is equal to 30 divided by 24. You know 6 goes in both of these numbers. 6 goes in 35 times, 6 goes in 24 4 times, and your answer would be 5 over 4 hours. Working together at their individual respective rates. Pipe A doing everything, the job in 5 hours, pipe B doing it in 3 hours. Together they were doing 1.25 hours. Or you can say 5 over 4 hours, but they would not fill the whole tank, they'd only do 2/3 of the tank. Anyhow, this question has been solved. Let's look at number 2. Question number 2 is this. Working alone, person A does a certain job in 12 hours. Working alone, persons B and C independently do the same job in 15 and 18 hours respectively. So here we have 12, here we have 15 and 18. What is the ratio in terms of the time required for A to do the same job versus B and C working together to do that same job? B and C working together. How would you go about doing this? Well, since you're doing a ratio here and keeping A separate, you don't have to do anything with A other than just document that A does that same complete job in 12 hours. What you have to do is worry about how long it takes for B and C to do that same job together. If B does this job in 15 hours and C does it in 18 hours, you know the equation will generally be, in terms of the total time required, it will be x over 15 for B plus x over 18 for C would equal to a complete job, which is a whole, which is a 1. From here you can do a common denominator. 15 and 18 would have a common denominator of 90. 15 goes in 96 times, you'll have 6x. 18 goes in 95 times, you'll have a 5x is equal to 1. You'll have 11x is equal to 90 and x is equal to 90 over 11. You know if you do 90 divided by 11, you're getting 8.18 hours. This corresponds to 8.18 hours. So B and C working together do that same job in 8.18 hours. A is doing it in 12 hours. So how would you do this ratio A to B and C? Well, you can do A is a 12 and then B and C is 90 over 11. Because it's saying what is the ratio of A to B and C, I'll do 12 divided by 90 over 11. Which will be, when you flip this around, you'll have 12 times 11 over 90. You can simplify things out. 3 goes in 12 4 times, 3 goes in 90 30 times, 2 goes in 4 2 times, 2 goes in 30 15 times. I'm getting 2 times 11, 22 over 15, and that would be the answer. The ratio of A to B and C is 22 over 15, and that right there would be your answer. Just for this type of question, don't make a mistake over here. What is the ratio of A to B and C? You want to put A here in the numerator, B and C in the denominator. If it's the ratio of B and C to A, you can put this in the numerator and this in the denominator. This right here represents our last question. Machine A, alone, working, doing a certain job, does it in 5 hours. We don't know what it is, but it's taking 5 hours for machine A. Machine B, working alone, does the same job in X hours. Together, however, when they work, they do the same job in 2 hours. We have to find X. What does X represent? The rate at which machine B can do that same job alone. So how do you start with this? Let's label A, let's label B. We know together they were doing a same job in 2 hours, that complete job in 2 hours. But machine A every hour completes 1/5 of the job because it works at a rate of 5. For machine A, you're developing this fraction 2 or 5 because here the numerator represents the time for both them working together. Denominator demonstrates the rate at which A is doing that job per hour, which is usually 1/5. 1/5 times 2 is 2 or 5 plus B. Well, we know how much it's working in terms of a group, in terms of A and B together, but we don't know what its independent rate is, 2 or X. And we know it's doing the whole job together, they're doing a complete job. And this right here would represent the equation. You know you'd have a 5x here in the denominator. You do the common denominator, 5 goes in x. X times, you'll have a 2x. X goes in 5x 5 times, and then you'll have a 10 is equal to 1. You'll do 2x plus 10 is equal to 5x because you'll cross multiply here. You'll do 3x is equal to 10, and then x is equal to 10 over 3, which is 1 over 3 hours. And that right there would represent the rate at which machine B is doing that same job alone. The answer here being 1 over 3. And this question has been solved for you, and it should be right. Just remember how these equations develop. There are multiple ways of doing the same equation or same type of problems. I'm just showing you one way. If you go back to the tags I've included for the 2 videos, I talk more in detail about how these equations are developed and why I am showing you the way I have. And that's it for this particular video. Thank you for watching. Have a good day. Bye.